This video is about how to sketch the graph. Look at the A. Consider the function f of x equals 27 over x squared minus 16x. Write down the domain and a vertical asymptote of f. We know this is a rational function. For rational function 1 over x, the domain will be x not equal to 0. Which means the denominator not equal to 0 to find the domain. For f of x, the denominator is x squared. Therefore, domain we will set up x squared not equal to 0. Square root both sides, we get x not equal to 0. Then the vertical asymptote line will be x equals 0. For B, sketch the graph of y equals f of x. For x is greater than or equal to -4, less than or equal to 3, and y greater than or equal to -50, less than or equal to 100. The word sketch. What's the difference between draw and sketch? For IB exam, sometimes you need to draw a graph. Sometimes you need to sketch the graph. Sketch a graph means making a general graph with the key points and asymptotes noticeable. Key points means x and y intercepts, local minimums and local maximums. Draw a graph besides making a general graph with key points and asymptotes noticeable. Try to accurately plot as many points as possible. When you draw a linear function, you must use a ruler. Even when you sketch a linear function, I recommend you should use a ruler too. How to sketch the graph of a function for HL level? Normally, there are 4 marks for sketching a graph. The first mark for X is labeled with the indicate skills and the correct window. Sometimes the first mark for correct domain and range. So from the question, you have to make sure which one is for the first mark. Second mark for smooth curve with correct general shape with a noticeable asymptote line if there is any. Third mark for x and y intercepts. The last mark for correct local minimums and maximums. Let's look at this IB graphing paper. The unit will be centimeters. It is 24 centimeters long and 16 centimeters wide. So how to decide the scale? Because they didn't give you the scale in this problem. We will do this 3 minus -4. You will get 7. We know this one is 16 centimeters. Let's think about this one is -4. So 1, 2, 3, 4, 5, 6, 7. This will be 3. Just count the units. 1, 2, 3, 4. This is 0. Then use a ruler to draw this x-axis. Remember, label x-axis. Then you will draw this y-axis here. After you draw this y-axis, then let's calculate the scale, because the scale is not given. 100 minus -50, you will get 125. We will use 25 as 1 unit. Make sure -50 and 100 clearly labeled. So this is a 25 and a 50, 75 or 100 here, label as a 100. Negative 25, negative 50. This is a 1. Remember the first mark, go to your label X and Y axis and the correct window. Correct window means the X is between negative 4 and 3. For Y is between negative 50 and 100. Sometimes the first mark go to domain and range. Then when we go to calculator, you will set up the same window. Go to calculator, put f of x into y1. So go to window. Minimum is negative 4. Maximum is 3. Scale is 1. We already set up 1 centimeter is 1 unit. For minimum, go to negative 50. Maximum 100. And scale we set up 25. Then you graph. You could say this is the graph look like. We can work out this 0 now. Second trace, press 2. I will put 0.5 as a left bound. Right bound, let's do 2. Enter, then enter. You will get answer 1.19 as a 3-sigma fix. For the minimum point, go to second trace, go to minimum point. This is negative 1, negative 2. We can make a negative 3 as the left bound. And make this is a negative 0.5 as the right bound. Then enter. You will get negative 1.5 or 36. This will be the minimum point. Then for HL level, most of the time you need to show the domain and a range. When x equals negative 4, I go to trace, put negative 4, enter. You will get 65.7. Then I press 3 for f of 3. You will get negative 45. For this window, try to figure out these two intersections. So I put y equals 100 for y2. Second trace, go to 5. Then enter, enter, enter. You will get 0.5 or 100. Now let's go to second intersection, second trace, 5. Then move the arrow close to that intersection. Enter, enter, enter. You will get negative 0.544, 100. Let's plot key points. First of all, let's plot the x-intercept. This is a 1.19, just an estimate. For the minimum point, it's a negative 1.5 or 36. 36, it will be here. Just estimate. For the domain and the range part, we know when x equals negative 4, you will get 65.7. 65, this is a 50. This is a 75. So 65 will be between these. It will be here. This is a negative 4, 65.7. when x equals 3, go to negative 45. It will be here, negative 45, negative 3. You remember this is a 25, and each small one will be 5. That's how get negative 3, negative 45. Then 0.5 100. It will be here. And negative 0.544. Let's label here. We know this is the graph from a graphing calculator. The pattern is over there. So we will sketch the graph like this. Then for this part, sketch the graph like this. Then for C, they ask you what's the zeros. We know that is 1.190. Then for D, find the local minimum points. That is negative 1.536. Let's go to E. Sketch the graph of the function g of x equals 20x plus 80 on the same axis. This is a linear function. We need to figure out x-intercept and y-intercept. For y-intercept, g of 0 equals 20 times 0 plus 80 equals 80. Y-intercept will be 0, 80. For x-intercept, we will make g of x equals 0. 20x plus 80 equals 0. Cross the river change sign. X equals negative 80 over 20 equals negative 4. X-intercept is a negative 4, 0. Let's plot these 2 points and then use a ruler to sketch this linear function. We'll look for negative 4, it's here. Then 80, this is a 75. We know this small unit is a 5, so it will be here. Then we use a ruler to connect these 2 points. You could say there are 3 intersections. Let's go to F. Solve f of x equals g of x for x. From the graph, we could say there are 3 intersections. We will use graphing calculator to figure out the intersections. So go to graphing calculator, go to Y2, we put in 20x plus 80. Then graph. We will figure out these 3 intersections. Second trace. Go to 5. Enter, enter, enter. You will get negative 0.703. Let's go to this one. So second trace. Go to 5. You can move the arrow close to this intersection. Then enter, enter, enter. They give you negative 2.04. We know the third intersection is this one. It's hard for you to move from this intersection to this intersection. So we will put a trace and then close. This is 1. So trace 1. Enter. Then this time do the second trace. 5. enter, enter, enter. They will go to the third intersection. That is 0.523. Now, let's go to F to solve f of x equals g of x. Since we already figured out 3 intersections, so the x-coordinate of these 3 intersections will be the solution for f of x equals g of x. That is x equals negative 2.04, negative 0.703, 0.523, negative 2.04, negative 0.703, 0.523. Let's go to number 2. Solve f of x greater than or equal to g of x for x. F of x greater than or equal to g of x, which means the graph above g of x will be the solution, which means this is the solution, and this is the solution. This is a solution. Do not forget this is a vertical asymptote line, x equals 0. So we can write down the solution. X less than or equal to negative 2.04, or x greater than or equal to negative 0.703, less than 0, or x greater than 0, less than or equal to 0.523. Let's go to number 3. Solve f of x less than g of x. The graph below g of x will be the solution, which means from here to here. And this. We can write down the solution. X greater than no equal sign because here is no equal sign. X greater than negative 2.04, less than negative 0.703, or x greater than 0.523.